Today's video is going to be about special products and multiplying polynomials. So in the first couple of examples, we're going to look at when you're multiplying a monomial against some other polynomial, whether it be a binomial, trinomial, or so on and so forth. So the important things about this is I've already marked on the side. First thing is you're going to treat problems like distributing. We're literally going to distribute something inside to another binomial, trinomial, or polynomial. Also, you want to make sure that we're being consistent with keeping our answers in descending order by degree. All right, so we always want to make sure that our answers are in standard form, which means that they are in descending order by degree. So for my first example, I am going to distribute this negative 2x to both of these terms inside. You always want to start and distribute your monomial inside to the other one. So when I do this, I get negative 2x times 4x. So we multiply the coefficients and then we multiply the variables. So 4 times a negative 2 is negative 8. And then we have x times x, and we just learned that before. If we have x times x, those both have a exponent of 1, and when you multiply them, you add the exponents. So this is going to become x squared. And then again, we're going to go into another term. We're going to multiply our negative 2x by our 7. Negative 2 times 7 is negative 14. And then we just have this x over here, so negative 14x. And I want to check and make sure it's in descending order. That's good. And there's my answer, negative 8x squared minus 14x. Now, you won't always have a binomial inside. Here, we have 3 terms inside the parentheses. And here we were kind of doing, on the first example, I don't want to say reverse distribution, but we were coming in from behind. And now we're going to come in from the front and distribute this to all 3 of those terms inside the parentheses. So again, I'm going to multiply my coefficients. Negative 4 times 3 is a negative 12. And now I'm going to multiply x times x. Well, I have 2 here and 2 here. That's a total of 4. Now, negative 4, again, times this 2 inside is negative 8. X squared times x to the 1. I have 2 plus 1 is x to the 3rd. And now I have negative 4 times a negative 6. And that is positive 24. And then x squared. So I'm literally just multiplying my coefficients and then multiplying my variables. All right. Now, we will look at an example where you are not multiplying by a monomial. You have a binomial multiplied by a binomial. So the way that we're going to do this is called, I'm going to write over here. So to multiply two binomials, we're going to use FOIL. And this is a pattern when you're multiplying binomials. So let's look at an example. And what this stands for is you have FOIL. This stands for first, outer, inner, and last. So let's look at an example of multiplying binomials using the pattern FOIL. So our first example is going to be 2x plus 3 times x plus 1. Okay, so we are going to use the pattern. So we are going to multiply our first terms together from the parentheses. So 2x is my first term in the first one, and I'm going to multiply it by my first term in the second. That's what f stands for. Then you're going to multiply your outer terms. So those are the terms on the outside. So you're going to multiply 2x times 1. That's the outer. Then you're going to multiply the inner. Those are the 2 on the inside. And then finally, you're going to multiply your last. So that's first, outer, inner, last, FOIL. All right, so let's see what I get when I do that. First thing I'm going to do like I said, is I'm going to multiply my first. So I have 2x and x, that's 2x squared. Now I'm going to go outer, 2x times 1, well that's 2x. My inner are 3 and x, so that's going to be 3x. And my last, I drew the arrow wrong. This last up here, sorry, that was my bad. This last should be these. That's your last, the ones that come last. I apologize about that. Okay, and then my last should be 3 times 1, and that happens to be 3. So now I have to simplify. If you notice, I do have 2x and 3x, so I can rewrite this. 2x squared plus 3 plus 2 is 5x plus 3. And that is my answer. All right, let's look at a couple more examples with that. My next example, again, is two binomials. So I have y minus 2 times y minus 3. So I'm going to do my first, my outer, my inner, and then my last. So my first is going to be y times y, which is y squared. My outside is going to be this y and this negative 3, which is negative 3y. My inside, I have a negative 2 and a y, which is negative 2y. And then I did that again with the last. I don't know why I keep doing that. Last is going to be this 2 to this 3. So negative times negative is a positive 6. So I have to go again and combine my like terms, if you notice in the middle. So I'm left with y squared, a negative 3 and a negative 2 is negative 5y plus 6. And that is my simplified version. So two more examples kind of similar to this. Actually, I think this is example 5. So I have 2k minus 4 squared. And what this means, right, we know that this just means that we're multiplying this by itself. So we can rewrite it as two binomials. And now I'm going to, again, follow my FOIL. First, outer, inner, last. You're essentially distributing each one in this first binomial to the one in the other. So I have 2k times 2k. 2 times 2 is 4. K times k is k squared. And then I have 2k times negative 4. That would be negative 8k. Again, in the center, I have negative 4 times 2k, which is another negative 8k. And then I have negative 4 times negative 4, which is 16. Again, I can combine my two middle terms. I have 4x squared minus 16, not xk, sorry, minus 16k plus 16. And that is my simplified version. All right, last one like this, till we look at not just two binomials. You might see this in a different way. Let's say we want to find the area of the given rectangle. And you have a rectangle. And this side, the bottom, is going to be x plus 3. And the top is 2x minus 4. Well, we know that the area of a rectangle is base times height, or length times width, I guess that would be a better way. Length times width. And we can plug those in now. We know area is equal to our length is x plus 3, and our width is 2x minus 4. So I can essentially use FOIL to simplify this to find my area. So I'm doing first, outers, inners, and last. So x times 2x is 2x squared. Now I have my outer x and negative 4, which is negative 4x. My inners are 3 times 2x, which is 6x. And then my last is I have a positive 3 and a negative 4, that's negative 12. Again, I could simplify in the middle. I have 2x squared plus 2x minus 12. And that is the area of my rectangle. All right, so I do want to show you an example where the two polynomials that we're multiplying aren't both binomials. So here I'm going to multiply k plus 4 times k squared plus 3 minus 2x. To do this, you have to make sure you're multiplying each term by each term or the other. So I'm usually take the one that comes out in front, so that's this k plus 4, and I have to distribute each one of these terms to every term in the trinomial over on the right. So I'm going to start with k. I'm going to distribute k to all 3 of those terms. So k times k squared is k to the third. K times 3 is 3k. K times negative 2 is negative 2k squared. Now I have to continue, and I did my k already, but I have to make sure that I distribute this 4 over there also. So 4 times k squared is 4k squared. 4 times this 3 in the middle is 12. And then I have 4 times negative 2 is negative 8. Negative 2k is negative 8k. So now I got to go in and clean it up a little bit. I have k to the third is my largest exponent, so I'm going to bring that out in the front. I did that one. Now I have 2k squared terms. I have a negative 2 and a positive 4, so that's plus 2k squared. Got rid of those two. Now I have 3k in the front and 8k in the back. That's negative 5k. Got rid of those, and I got this little baby constant coming down at the end. So that gives us k to the third plus 2k squared minus 5k plus 12. So we're just making sure. You can't necessarily use FOIL when you have this situation. FOIL is only for a binomial multiplied by a binomial. This, you have a binomial in the front multiplied by a trinomial. So just make sure every single one of those in your whatever's in your parentheses first goes to all of the ones in what's on the other side. All right, so we do have a couple special cases we have to talk about. So these are special product patterns. And there's 2 of them. The first one is the sum and difference pattern. And the second one is the square of a binomial pattern. So the first one we're going to look at is the sum and difference. And what this says is that you have A plus B and A minus B. It's going to equal A squared minus B squared. So you're squaring the first terms, and then you're squaring the last terms. And there's a reason that this works out like this. And this is every time. When you have, they call it the sum and difference because you have the sum of 2, and then you have the difference of 2. And that's going to be just square them. It's the difference of their squares. I'll show an example of why this works just in case you can't remember this for some reason. So if I have the example 3x plus 2, there's my sum, 3x minus 2, there's my difference, and I FOIL this, I get 9x minus 6x plus 6x minus 4. These two here right in the middle, negative 6x and positive 6x. That's going to happen every time where these two cancel out, and all you're left with is 9x. Sorry, that should be 9x squared. 9x squared minus 4. And that's the rule. You can just square your first terms. So 3x times 3x, and that's minus your last terms, 2 times 2. and we would have got 9x squared minus 4. And you get the same thing. So if for some reason you forget this pattern, you can go back to the original of just squaring the first terms and squaring the last terms. So let's look at another example. For this, I have x plus 5, x minus 5. So I know that I'm going to square my first term. So x squared, x times x is x squared, minus 5 times 5 is 25. And there it is. You don't have to do any of the foiling. All you have to do is square your first and square your last. One last example of this, which you will see, x plus 2y times x minus 2y. Again, it is still the sum and difference, so I'm going to square my x. X squared is just x squared, minus, now I have to square 2y. I have to square the, remember, it's like saying 2y squared. We've done this. You have to distribute this in. So 2 squared is 4, and y squared is y squared. So you're left with x squared minus 4y squared. All right, one last thing. We did the sum and difference. We need to look at the square of a binomial pattern. So we're going to do the square of a binomial. So there's two parts to this. First one, if a plus b squared means a plus b, which we know, then a squared, then it's equal to a squared plus 2ab plus b squared. Likewise, if you have a minus b, which we know means a minus b times a minus b, then a squared minus 2ab plus b squared, it's equal to that. Then equals, I guess I'm going to equal sign there. Okay, so let's look at examples of this. First one, I have m plus n squared. Okay, so we have a couple steps. First thing you're going to do is square first term. Then you're going to multiply first and second and double that. And then finally, you're going to square the last term. So I'm going to square my first term, so it would be m squared. I'm going to multiply my 2 and double that. So that would be 2mn positive. If this is positive, this is going to be positive. If you notice up here, it was negative and it was negative there. And then I have to square my last term. N squared is just n squared. So that's what I'm left with. Again, if you forget this rule, you can always just turn this into m plus n, and then FOIL it. You'll still get the same answer. All right, another example. Two more. 3x minus 2 squared. So first thing, I have to square my first term. 3x squared times 3x squared is 9x squared. I have to multiply the two of them together. So I have negative 2 times 3x, that's a negative 6x, and I have to double that, so it'd be negative 12x. And then negative 2 squared is 4. You notice that this negative comes in because when you multiply these two together, it's a negative. All right, last example. We have 7y plus 2, and that's squared. So I'm going to square my first term. 7y times 7y is 49y squared. I'm going to multiply them together. 7 times 2, or 7y times 2 is 14y, and I have to double that. So that would be 28y. And then I'm going to square my last term, which is 2, so I would get 4. All right, so I know there was a lot of information in the video today, but we will practice more in class.